The French created a revolutionary armored vehicle with 8 wheels, 4 of which were steel, and would retract while driving on asphalt. It was born twice, had 2 drivers, and a revolutionary turret. And its most famous service episode didn't happen on the battlefield. Why? We'll tell you about this at the very end of this incredible story. But first, let's figure out how French engineers even came up with such madness. The story begins in 1938, when Europe was rapidly rolling toward a new Great War. The French military command realized an unpleasant truth. Their armored vehicles were hopelessly outdated. Light reconnaissance vehicles couldn't penetrate enemy armor. Heavy tanks were too slow, and there was a huge gap between them. They needed a universal soldier capable of quickly scouting enemy positions, engaging their light vehicles, and not getting stuck in the mud somewhere in North Africa. The French General Staff announced a competition to create a powerful armored car. The requirements sounded simple: high speed, good armor, serious armament, and the ability to drive on any terrain. As usual, the devil was in the details. The Panhard company took on the project under engineer Louis Delagard, and what he came up with looked so strange that many military officials initially thought it was a joke. Delagard proposed an 8x8 scheme. Not 4 wheels, not 6, but all 8. Moreover, 4 regular rubber wheels were positioned at the front and rear, and between them were 4 more metal wheels with traction cleats. The logic was this: on asphalt, the vehicle drives only on rubber wheels, like a regular car, reaching speeds up to 80 kilometers per hour. And when you need to go into mud or sand, the metal wheels lower and turn the armored vehicle into an all-terrain vehicle with ground pressure of only 0.7 kilograms per square centimeter. But this was just the first oddity. Delagard made the hull completely symmetrical front and rear. Why? And here's where it gets really interesting. He seated 2 drivers back to back. One controlled forward movement, the other backward. The vehicle could accelerate to 80 kilometers per hour in either direction without turning around, came under fire. Instead of slowly turning around, exposing your side to enemy fire, you just hit the gas and take the vehicle backward at the same speed you arrived. The hull turned out low and squat, only 1 meter 80 centimeters tall. Frontal armor reached 60 millimeters, which by 1939 standards was very solid for a reconnaissance vehicle. Most anti-tank guns of that time simply wouldn't penetrate such protection at distance. But then the French outdid themselves. On the roof of the hull they placed a revolutionary oscillating turret. This was the world's first design of this type. The turret consisted of 2 cylinder halves inserted into each other. The lower cylinder was tilted, and its raised edges held the trunnions of the upper half. When the turret rotated, both halves rotated simultaneously, and when vertical gun aiming was needed, the upper half simply oscillated relative to the lower one. No complex mechanisms, no extra parts. Brilliantly simple and simply brilliant. In this tiny turret sat the commander, who was also the gunner and loader all in one. Armament consisted of a 25mm SA-35 gun and a 7.5mm caliber machine gun. For 1939, this was quite decent equipment, capable of dealing with most enemy light tanks. The engine produced only 85 horsepower, but thanks to the low weight of about 9 tons, the vehicle accelerated to 80 kilometers per hour. Range was 400 kilometers, allowing deep raids into enemy rear areas. And here the French encountered a problem no one had foreseen. The prototype was built in autumn 1939. Testing went brilliantly. The vehicle showed excellent cross-country capability and reached the promised speed. The armor held against hits. The military was delighted. On May 1, 1940, even before all testing was complete, the Ministry of Defense placed an order for 600 vehicles under the designation AM-40P. Production was planned to be completed by summer, with the first 100 expected in the second half of 1941. But history had other plans. On May 10, 1940, the German invasion of France began. Blitzkrieg struck French positions with monstrous force. In 6 weeks, the French army lost about 1,749 tanks out of 3,000. The country capitulated on June 22, and all grand plans for new equipment production collapsed in an instant. By the time of capitulation, not a single production vehicle had been made, only one prototype. And here the French made a desperate decision. To prevent this unique development from falling into enemy hands, the only AM-40P specimen was urgently sent to North Africa, to Morocco. The vehicle was loaded onto a ship and evacuated from occupied France at the last moment. And what happened next, no one knows. The prototype arrived in Morocco in summer 1940 and disappeared without a trace. According to one version, it was hidden in the desert, buried in sand to conceal it from Vichy government collaborators. According to another, the vehicle was disassembled and distributed to different warehouses. There's even a version that the prototype was found and destroyed, after all. One thing is known for certain, this vehicle did not survive to our days, and its exact whereabouts from 1940 to 1945 remain a mystery. Panhard factories near Paris were occupied by the Germans after the armistice of June 22, 1940. All work on the project ceased. Most of the design documentation was destroyed, so it wouldn't fall into occupiers' hands. It seemed the mad idea of Delagard died along with the Third Republic. Panhard engineers were forced to work for the German war machine, producing trucks and spare parts. No one remembered the revolutionary 8-wheeled armored car. Europe burned in the fires of war. France was occupied, and somewhere in the sands of Morocco lay the only prototype of a vehicle that could have changed the course of combat operations. Meanwhile, the war went its course. French colonial troops in North Africa first obeyed the Vichy government, then sided with the Allies after Operation Torch in November 1942. Americans and British landed in Morocco and Algeria, drove out Axis forces, and began an offensive on Tunisia. And the AM-40P prototype continued to lie somewhere, forgotten by all, years past. France was liberated in August 1944. Paris rejoiced. De Gaulle triumphantly walked down the Champs-Élysées. The country began to recover from occupation, but the army was in catastrophic condition. Armored vehicles were either destroyed or hopelessly outdated. New vehicles urgently needed to be created. And then someone from Panhard Engineers remembered the 1939 project. Almost no documentation remained. The prototype was lost. But the idea was so good that the French decided to revive the project from scratch. And here began a completely new chapter in the history of this mad machine, which would ultimately serve France for almost 4 decades and become one of the most recognizable symbols of French armored vehicles. The war ended, but France lay in ruins. The colonial empire was cracking at the seams, and without modern weapons it was impossible to hold Indochina and North Africa. In September 1949, the French Ministry of War announced a new competition for a reconnaissance armored vehicle. Requirements were the same as in 1938, but now the bar was raised. Panhard submitted its project based on the pre-war model 2011. In December 1949, the military chose the winner. It was Panhard with its mad 8-wheel design. The project received the designation Panhard 212 and later was renamed EBR, which stood for Engine Blinde Reconnaissance Armored Vehicle. But this was not at all the prototype that disappeared in Morocco. Almost no documentation remained, so engineers had to create the vehicle anew, and it turned out that in 10 years the world had changed beyond recognition. During the war, tank gun calibers grew by 1.5 to 2 times. The 25mm gun of the pre-war prototype now looked like a child's toy. The French made a radical decision. The new vehicle would get a 75mm SA-49 gun, the same one mounted on American M4 Sherman tanks. This was a powerful gun with a muzzle velocity of 600 meters per second, capable of penetrating 70mm of armor at 1,000-meter distance. But how to squeeze such a monster into the low hull of a reconnaissance vehicle? The answer was in the oscillating turret. The FL-11 turret was designed specifically for the 75mm gun. It consisted of 2 halves, but was now larger, stronger, and accommodated 2 men, commander and gunner. The gun was rigidly attached to the upper half of the turret, which oscillated up and down for vertical aiming. The crew increased from 2 to 4 men. 2 drivers sat in the nose and stern of the hull back to back. Commander and gunner were placed in the turret. Each driver had their own full set of controls and could drive the vehicle at full speed in their direction. What do you think happened when this system was tested in practice? It turned out the idea was brilliant. The vehicle really could instantly retreat from under fire in reverse, developing the same speed as forward. No turning around, no time wasted. Spotted the enemy, fired, and immediately rushed backward at full speed. For the crew, this meant a sharp increase in survival chances. The hull was made low. Height was only 1 meter 3 centimeters without the turret. With the turret, total height reached 2 meters 32 centimeters. The low silhouette made the EBR a difficult target, especially in desert terrain. Armor, hull and turret front 40 millimeters, sides 20 millimeters. Why did the French sacrifice armor? To maintain high speed and cross-country capability, they had to lighten the vehicle. The 8-wheel system was preserved but improved. The 4 outer wheels received tires of special construction. Inside the tires were Viel Picard tubes filled with nitrogen under pressure and divided into many cells. If a bullet pierced the tire, only one cell lost pressure, the rest continued to hold shape. The wheel didn't deflate, and the vehicle could continue moving. The 4 central wheels were metal, with aluminum rims and steel traction cleats. On highways, these wheels were raised by a hydraulic system, and the vehicle drove only on 4 rubber ones, reaching speeds up to 100 kilometers per hour. On off-road, the metal wheels lowered. Ground pressure dropped to 0.7 kilograms per square cm. And now the most interesting part about the engine. Panhard engineers created a unique motor specifically for the EBR. It was a 12-cylinder opposed engine with air cooling, producing 200 horsepower. The whole secret was in its thickness, only 22 centimeters. The engine was flat as a pancake but produced 200 horsepower. This motor was placed under the floor of the fighting compartment, right under the turret. On one hand, this was a brilliant move. The engine didn't take up space in the hull. On the other hand, the French created a headache for themselves for a decade ahead. Guess what had to be done for serious engine repair? That's right, completely remove the turret with all armament, instruments and ammunition. This turned any major repair into a multi-day epic. In field conditions, repairing the engine was practically impossible. The vehicle had to be evacuated to base, which in colonial war conditions somewhere deep in the Sahara became a serious problem. But there were also advantages. The engine ran on low-octane gasoline, critically important for an army fighting thousands of kilometers from home. 2 Zenith carburetors ensured reliable operation in any climatic conditions, from 50-degree Sahara heat to European winter cold. Range reached 650 kilometers. The transmission received a reversible gearbox, allowing full engine power transmission to any pair of drive wheels regardless of direction of movement. All 8 wheels were permanently driven. The vehicle overcame trenches 2 meters wide, fords 1 meter 30 centimeters deep, and vertical obstacles 40 centimeters high. The first Panhard 212 prototype was tested in 1950. The military was satisfied. On July 14, 1950, during a parade on the Champs-Élysées, the new armored car was first shown to the public. This was the second birth of the vehicle 10 years after its ancestor disappeared in the sands of Morocco. In 1951, serial production began. The model received the designation EBR 75, 1951 model. From 1954, 836 units of the French army. Already during production, it became clear that the SA-49 gun was insufficient. The military wanted more fire and higher rate of fire, and they got it in the next modification, received a new toy, the AMX-13 light tank with revolutionary FL-10 turret, and allowed fire at insane speed. Then at the EBR, and asked why can't we put this turret on. Panhard engineers replied that technically it was possible. The FL-10 turret and the FL-11 turret from the EBR had the same turret ring diameter of 2 meters 10 centimeters. The problem was weight. The FL-10 turret weighed significantly more. The suspension had to be reinforced, otherwise the vehicle would simply fall apart on the first bump. Work began in 1954. The chassis was reinforced, torsion bars replaced with more powerful ones. Vehicle weight grew from 13 to 15.5 tons. The new modification received the designation EBR 75th 1954 model. And now let's understand how this mad oscillating turret with autoloader actually worked. The turret consisted of 2 parts, upper and lower, connected by trunnions. The lower part was attached to the hull and rotated 360 degrees. The upper part oscillated up and down, providing vertical gun aiming. The trick was that the gun was rigidly attached to the upper part of the turret. When the barrel needed to be raised, the entire upper half of the turret rose along with the gun. This allowed installation of an autoloader that worked only at a strictly defined position of the breech. In the rear of the turret, in a huge bustle, were 2 drum magazines with 6 rounds each. The drums were located left and right of the gun axis. Guess how long reloading between shots took? Only 5 seconds. The feed mechanism automatically extracted a round from the drum and fed it into the breech. The breech closed and the gun was ready to fire. Spent casings were automatically ejected outside through a special hatch. The crew didn't need to do anything, just aim and shoot. 12 rounds in the drums allowed continuous fire for over a minute. For a reconnaissance vehicle, this was more than enough. Attack, fire 12 rounds and escape at maximum speed. But what happened when the drums emptied? Here problems began. To reload the drums, the vehicle commander had to manually pull rounds from stowage in the hull and insert them into drum slots. Loading 12 rounds in the cramped, oscillating turret took at least 5 minutes, usually much longer. That's why French tactics prescribed using the EBR for sudden strikes, not prolonged battles. The SA-50 gun was significantly more powerful than its predecessor. Barrel length was 57 calibers versus 30-something for the SA-49. Muzzle velocity increased from 600 to 1,000 meters per second. Armor penetration nearly doubled. At 1,000 meter distance, the round penetrated 100 millimeters of armor, allowing destruction of medium tanks like the Soviet T-54. The muzzle brake reduced recoil, allowing the light chassis to withstand firing the powerful gun. Horizontal traverse speed reached 30 degrees per second. Total ammunition was 36 rounds, 12 in autoloader drums and 24 in hull stowage. And here begins the most interesting part about the strange wheels. Many still don't understand why the French invented this system with retractable metal wheels. The logic was simple but brilliant. On asphalt, rubber tires provide excellent traction, low noise level and high speed. The vehicle races at 100 kilometers per hour almost silently, critically important for reconnaissance. But in sand or mud, rubber wheels start to sink. 4 wheels can't cope, and the vehicle gets stuck. The solution: add 4 more wheels, but metal ones with developed traction cleats. When the vehicle leaves asphalt, the driver presses a button. The hydraulic system lowers the metal wheels, and ground pressure drops almost threefold. Metal wheels were smaller than rubber ones. They had aluminum rims with welded steel traction cleats. Each metal wheel weighed only 80 kilograms versus 250 for a rubber one. Weight savings was 680 kilograms. How long do you think raising or lowering the metal wheels took? About 15 seconds. The driver pressed a button. Hydraulic cylinders were activated, and wheels smoothly lowered or raised. This could be done on the move, though usually the vehicle was stopped. When metal wheels were lowered, the vehicle turned into a true all-terrain vehicle. It drove through sand where any ordinary vehicles would get stuck, crossed swamps, forded water up to 1 meter 30 centimeters deep. Ground pressure in 8x8 mode was 0.7 kilograms per square centimeter, less than a human footstep. But there was a flip side. On metal wheels, speed dropped to 60-70 kilometers per hour. Noise increased many times over. Traction cleats pounded the ground, creating wild roar. Stealth could be forgotten. The vehicle was heard a kilometer away. Fuel consumption increased by half. Therefore, the application tactics were, on road marches, drive in 4x4 mode. Fast, quiet, economical. When approaching off-road, switch to 8x8 mode, sacrificing speed for cross-country capability. After completing the task, return to the road, raise metal wheels and race again at maximum speed. Steering worked only on the 4 rubber wheels, front and rear. Metal wheels didn't turn. This simplified the design but limited maneuverability off-road. Turning radius was only 6 meters, which for a vehicle 6 meters 15 centimeters long was an excellent indicator. The suspension of all 8 wheels was independent on torsion bars. This ensured smooth ride even on rough terrain. The vehicle could cross trenches 2 meters wide, vertical obstacles 40 centimeters high, and climb slopes up to 60% grade. From 1954 to 1956, 279 vehicles of the 1954 model were built. They went to elite reconnaissance units and proved themselves excellently in combat. Rate of fire tripled compared to the first model. Armor penetration doubled, cross-country capability remained at the previous high level. But the French didn't stop even there, because in the 60s, tanks appeared against which the 75mm gun no longer worked, and even more powerful armament was required. which would turn the EBR into a real tank killer. In the early 60s, the world of tanks changed again. The Soviet T-62, American M60 Patton, and British Centurion appeared with armor that the 75mm gun could no longer penetrate. The French army faced a choice, either retire the EBR or modernize it for new realities. The military chose the second option. In 1963, a rearmament program began. Guess what they decided to do with the 836 vehicles of the 1951 model with outdated 75mm guns? They weren't scrapped. The barrel of the 75mm SA-49 gun was bored out to 90mm caliber and a muzzle brake was installed. The result was a low-pressure SN-90 F2 gun specifically developed for firing shape-charge rounds. From 1964 to 1968, 650 vehicles underwent modernized F2 gun of only 750 meters per second, but the trick was using shape-charge ammunition that penetrated armor, not with kinetic energy, but with a directed explosion. The shape-charge round penetrated 320 millimeters of armor at any distance, allowing destruction of practically any tank of that time, including Soviet T-54 and T-55. The remaining vehicles were outdated 75 from combat units. Some were converted into command vehicles, with guns removed and radios and map tables installed. French tankers nicknamed them grasshoppers for their ability to quickly jump around the battlefield transmitting orders. And where did these vehicles actually fight? The main battlefield for the EBR was Algeria. From 1954 to 1962, a war for independence raged there. The French army used EBRs for road patrols, convoy escorts, and raids on rebel bases. Speed and powerful armament made the vehicle ideal for such tasks. The Foreign Legion actively used EBRs in Algeria and the Sahara. The 1st Cavalry Regiment of the Legion received these vehicles among the first. Legionnaires wore light khaki berets and were proud of their 8-wheeled monsters. The vehicles proved their value in the desert, where their cross-country capability and range were critically important. In combat, it turned out that the bidirectional driving system worked brilliantly. Crews learned to use the tactic of attack, shoot, reverse retreat. The vehicle would jump out of cover, fire 12 rounds from the autoloader, and instantly retreat backward at full speed without turning around. For the enemy, this looked like lightning. It was impossible to predict where the vehicle would appear and where it would disappear. Metal wheels in the desert showed themselves excellently. Sahara sand could stop any ordinary car, but the EBR on 8 wheels went everywhere. True, the noise was hellish. Legionnaires joked that the enemy heard the EBR before seeing it, but getting stuck was practically impossible. But there were also problems. The engine under the turret remained a headache for mechanics. In desert conditions where sand got everywhere, any serious breakdown meant evacuating the vehicle to base. Removing the turret in field conditions was unrealistic. Crews tried to conduct the most thorough maintenance to avoid major repairs in combat. Sahara heat, up to 50 degrees, tested the equipment to its limits. Air cooling of the engine coped, but the crew inside was cooking. The turret turned into an oven, especially after firing when additional heat came from the gun. They had to drink liters. The Portuguese army bought 78 vehicles of the 1954 model with FL-10 turret. The Portuguese fought in their African colonies, Angola, Mozambique, and Guinea-Bissau from 1961 to 1975. The 1st Cavalry Group received the nickname Dragons. Their EBRs patrolled jungles and savannas, fighting guerrillas. In the jungle, metal wheels proved less useful than in the desert. Wet soil and dense vegetation limited cross-country capability. But on roads and in savanna, the vehicles showed themselves magnificently. The autoloader gave huge advantage in fleeting encounters with rebels. The Portuguese also used a special EBR VBTT version, an armored personnel carrier based on the EBR. 28 such vehicles were built specifically for Portugal. Instead of a turret, they installed an open mount with a 12.7mm machine gun, and inside was a landing party of 12 soldiers. These vehicles accompanied combat EBRs, providing infantry support. Some EBRAs went to Morocco, Tunisia, Mauritania, and even West Germany and Indonesia. In total, during production years from 1950 to 1960, About 1,000 vehicles of all modifications were built. This was a serious success for the French defense industry. In the French army, EBRs served until 1987. 36 years of service for an armored car is an outstanding term. The vehicle was replaced by the more modern AMX-10RC with 6x6 wheel formula and 105mm gun, but the EBR remained in memory as one of the most successful and unusual reconnaissance vehicles in history. And now it's time to tell about the most famous episode of EBR service, which happened not on the battlefield but at a funeral, and which we promised at the very beginning of this story. On November 9, 1970, Charles de Gaulle died at his residence La Boisserie from a ruptured aneurysm. The greatest French leader of the 20th century passed quietly, without witnesses. The world mourned. 80 heads of state arrived in Paris. But de Gaulle had written a will back in 1952. He wanted a simple funeral in the village of Colomby. No presidents, ministers, deputies, only family and military, without music or orchestras. And here a question arose: what should carry the coffin from the residence to the church? A modest but dignified vehicle was needed. Someone remembered the Panhard EBR, a vehicle embodying French military genius, but the turret was removed completely. You can't carry a general's coffin on a combat vehicle with a gun. On November 12, around 3 p.m., the coffin covered with the tricolour was placed on the EBR platform. The vehicle slowly moved forward. Along the road stood thousands of people. As the procession passed, people cried, saluted, raised 2 fingers, the victory sign. The bell tolled a funeral knell. Why specifically the EBR? This vehicle embodied everything de Gaulle valued: unconventional thinking, unique design, persistence, 2 births, 40 years of service, effectiveness in colonial wars that de Gaulle concluded, modesty. Without the turret it looked simple, but those who knew understood this was a legend. At the church, the coffin was removed. 12 young residents of Colomby carried it inside. The mass was short and simple. De Gaulle was buried next to his daughter Anne. On white marble, a simple inscription, Charles de Gaulle 1890–1970. The EBR completed its final mission. The vehicle that was born twice, fought in Algeria and Angola, became the last transport of the greatest Frenchman. This was an honor few were granted. If you liked this story, subscribe to the channel, give it a like. In future episodes we'll tell you about other mad military equipment projects. Until we meet again.